With that said, I'm going to go ahead and bring Sid online here in just a moment. Sid, you are now set up as a presenter. Sid is going to be talking to us today with regards to the management plane troubleshooting. Sid's a staff's tech support engineer with RAID and L7 technologies, as is Angelo, as I said, who'll be answering the questions in the chat. Sid, are you there?
Hi, Charles. Yes, I'm here.
Fantastic. Sid, I will go ahead and hand the show over to you. It is all yours, sir.
Thank you, Charles.
Of course.
Is my screen visible?
Yes, we see your screen there.
All right. Okay. Hello, everyone. Thank you for joining. We'll start the session. It's a small discussion over management plane. If you have any questions, any queries, please feel free to write your question in the chat. I have my colleague Angelo moderating the chat, and he'll be able to answer your queries. And we can take some questions later at the end of this presentation as well. So let's go and start our session. When we talk about management plane, or when we talk about Palo Alto firewalls, we all know Palo Alto firewall comprises of management plane and data plane, but both management plane and data plane are implemented in individual software programs which are called daemons, okay, or services. So we have about over 100 individual services or daemons running on the firewall. Some of the daemons also write their own logs. Okay, service daemon logs can provide valuable information for troubleshooting. It may include debug level property that sets a type of events logged. Generally, when we talk about daemons, all the daemons are configured by default and info level. However, some of the daemons may include debug level property. This can be displayed locally within CLI, or these can be exported and read outside of the firewall with some editors like Notepad or Notepad++, right? And how you can extract these daemon logs is through the TSF of the firewall or Panorama. Some of the daemons which we actually use to troubleshoot in our day-to-day life are highlighted here over in red. You can see if when you're troubleshooting issues related to authentication on the device itself, you will be going to the auth log or auth daemon. When you're troubleshooting VPN related issue, you would have to go through ikemanager.log or ikemgr.log. When we are collecting packet diag, or when we are taking a debug on the device itself, we'll be going through pan-packetdiag.log. To view the daemon or to view the log file, the command is less mplog and the daemon name. Some of the management plane services. So on the left, you can see these are process and daemons. So management server, it implements management services, handles configuration management, commit operation and reporting, and it is running as MGMT server or management server. So this daemon is used to manage the device itself. If you want to go to the log of this daemon, the log file name is ms.log. Device server or config D, it pushes the configuration to the data plane and handles various communication with the data plane such as URL lookup. The log to view is devserver.log or config.d.log. For HA, high availability, manages high availability status configuration sync. The log file name is HA event.log. Now, when we talk about logging, we have logging daemon. So some of the logging daemons are log receiver. It records the traffic log sent from the data plane. The log file is log receiver.log. syslog-ng handles log forwarding. syslog-ng.log, where data receiver records URL log and pcap sent from data plane. The log file name is where receiver.log. Web server implements management user interface. Log file name is fweb3 webserver.log or access.log. L3 service implements captive portal, NTLM authentication, URL block pages on the device. Log file name is fweb3 l3 svc.log. auth for authentication related issues. The log file name is auth.log. CryptoD, which encrypts and decrypts password and private keys on the device. The log file name is cryptod.log. User ID, when we are troubleshooting or configuring user ID related things on the device, the log file name is useridd.log. SSL manager or SSL MGR, it is used to fulfill OCSP and CRL queries from management plane and data plane services and manages the OCSP and CRL repository. The log file name is sslmanager.log. SSL VPN implements web-based global protect features. It is running on the device and the log file name is appweb3 sslvpn.log and sslvpn underscore ngx underscore error.log. RAS Manager also for Global Protect provides support for Global Protect remote access login, rasmanager.log, and IKEMGR and Key Manager to manage ISAKMP and the IPsec key repository. It can be used for Global Protect as well as normal VPN connectivity on the device itself. The log file name is IKEMGR and keymgr.log. So service daemon log data, debug levels are individual configurable. That means the daemons which are running on the device and logging, not all daemons are logging debug level information. By default, those daemons will be in info mode. But some of the daemons are configured with debug level information as well. You can display service log on the firewall using the below CLI commands. To display management plane related logs, the command will be less mplog and the log file name. If you want to view a live log, you can run the command tail follow yes mplog and the log file name. And if you want to match any pattern on any log file, the command is grep mplog, log file name, pattern, and enter the pattern. So this is for management plane. We have the same set of commands for data plane. The only difference is we use dp.log over here. And for management plane, we have mp-log. Some of the important cron jobs which is running on the device itself, you can see it's displayed over here. When we talk about report generation on the device, report is generated every day at 2 a.m. App stats generation for ECC report runs every 15 minutes. Content AV URL update under the dynamic updates, this is configurable. Panorama report generation once per hour. EDL, FQDN refresh, and wildfire updates all are configurable. So you can set these reports as per your requirement. Once per day, once per 24 hours, once per week, once per month, whatever you like. As I mentioned, all the daemons are not configured with debug level. Every daemon is set with a separate log level. So these are the log level: error, warning, info, debug, and dump. Some daemons configured with error and warning. So some services or daemons only support an error or warning option. And then most of the daemons will be configured with info mode. And if you need to collect debug level information for those daemon, we would have to configure debug on it. All right. So to view the daemons which are running on the device and the services associated with it, we can use this command debug software logging level, show level, services, all services. So let's just log into a device right now and run this command.
If you want to, at the bottom of the screen there, you've got that pop up. You can hit that button that says hide and get rid of that little box at the bottom there. There you go.
All right. So if you want to view the current debug levels, we can use this command debug software logging level, show level, services, all services. So I'll just copy and paste it on my device. I have a 320 device in my lab which I'm using. So debug software logging level, show level, services, all services. So it is going to display all the services right now running on the device. So we can see some of the services in info mode. All right. If I need to verify any services running one, okay, no one. Okay, no error, but let's see if we have anything in debug. Hmm. Okay, I think the match thing is not working over here. Let's confirm, is it? Oh, no, it's working. So I don't have anything running on my device in any other mode other than info. Okay. So all the daemons running are info mode. However, there will be certain requirement where you need to collect extensive logging for the daemon to troubleshoot any issue, because info mode sometimes may not be sufficient to troubleshoot any issue. So use cases or examples for routing, we recommend to collect logs in debug mode. For advanced OSPF or BGP issues, for IPsec, it's very important to collect an IKA debug so that we can get debug level information when we're troubleshooting IPsec related issue. And in some rare cases where the cases are escalated to engineering and engineering requires debug level logging so that they can collect the logs and understand what could be causing the issue. So if you want to run the command to see all the services, you can run the command debug software logging level set level default service all services. If you want to view any specific service, you can use the command debug software logging level set level default service and the service name. Okay, and if you want to change the logging level, the command is debug software logging level set level. So let's just change any of the log. So debug set feature, sorry, set level. These are the level available: debug default, dump, error, info 1. I'll use debug service and I'll do it for auth t. Okay, let's verify. So now the auth d service is configured in debug mode. So I can troubleshoot auth d related issues and the logging will be done in debug mode. Once I'm done, I'll switch back to the info mode or the default mode. So I can use the same command and switch the logging level to info mode. Let's verify it again. So this is now in info mode. Let's check for one more thing. IKMGR. So by default, Ike Manager is also in info mode. Let's switch Ike Manager to debug. So you can see Ike Manager is in debug mode. Now, if I don't know, if I don't want to do or change the daemons back to info mode individually, and I have switched a lot of daemons to debug mode, so I can do one by one, or I can use the default command as well, where it will switch everything to default. So individual and default both. So next is gathering more information on the device. So how to monitor daemons on the device? So first of all, if you want to verify what are the daemons running on the device, you can use the command show system software status and you can see the daemons running on the device. So in my device, if I run show system software status, you can see what are the things running on the device, and you can also see some of the daemons have a PID associated with it. This is very important because whenever you are upgrading the device and after reboot some of the services are not working or your device is not properly functioning, verify the daemons running and check is there any of the service which is not running. If that's the service causing the issue, we may need to restart the service or troubleshoot what could be the issue and why the service is not running on the device itself. So you can see what are the services running over here, and you can see process ID or PID associated with that services. So how to monitor daemons? You can verify through web interface dashboard or use SNMP. Verify system logs. If any of the daemons causing the issue, there will be a system log generated for it. Check for individual services under show system software status and show system resources. And to view the log of any of the daemon, use less or tail command to view the log. Let's also verify odd d log with the command less mplog odd d. So this is authentication log. You can see all the logs being generated over here, and I can just like issue is already triggered and I need to verify the log of a certain timestamp. I can just open the odd file and go to that timestamp when the issue occurred and read the logs over there. If I am troubleshooting it live, so I can use the tail command, tail follow yes mplog auth t. So here it is waiting for a new log file to be generated. So suppose if I try to log into my device, so here you notice I tried to log in and the password was incorrect or whatever happened, an odd D log was generated. So this is a live log which just got generated. So the tail follow yes will help you generate or view a live log when you're troubleshooting any issue on a live environment. Crash files, if there are any crash files, if you have observed any crashes, you can verify the crash files under show system files. So if there are any crash observed on your device, there will be a crash file generated and you can view the crash file over here. If you observe any crash on the device, please reach out to the TAC team, upload the crash file to the TAC case, and we'll review why the crash occurred. So there will be backtrace files and crash files associated with the daemon which actually crashed, and the files will be generated over here with the timestamp. So web interface tools or dashboard and system logs. You can see the system services on your dashboard. Let me log in and show you the dashboard on the device. So this is the dashboard. At the bottom, these are the system resources over here and system logs. System logs will be under the monitor tab. So monitor, on the left, you will see system logs. All right. And then you can verify the system logs if you're observing any issue related to any daemon and that is causing the issue. You will say system log getting triggered and generated over here. Right. To review service log file, you can generate the tech support file, download and unpack and examine. Most of the logs you will need are in this directory, var log pan. Backtrace files are under var course crash info. So whenever you are observing crash, download it and upload it through the tag on the tag case, and you can file the crash file under var course crash info. Show system resource command displays statistics on the management plane. So it sorts CPU by so it sorts process by CPU use, lists high-level statistics such as uptime, memory, and task, and provides a follow option to display in-live monitoring interactive mode. Okay, it is very useful to detect memory leak and swap issues on the device. All right, so you can use this command show system resources and get this output. So show system resources. So you can see it's my lab device, so it doesn't have a lot of activity. But when you are in production and when you run this command, you will see a lot of information over here. What are the processes consuming a lot of memory? Right now, only one user is logged in. Load averages, total task, one task is running, 250 sleeping task, CPU percentage, and memory and swap memory. Okay, so all this information is over here. Any of the daemon consuming any like m- memory which is actually more than expected, we can get information from here. And this is a live information. You can use interactive commands for top, or the other interactive commands available are over here. You can use interactive command or the keyword M to sort by memory use, and spacebar to refresh. And if you want to quit it, you cannot use Control C, you have to use alphabet Q. Okay, command options within top are case sensitive. All right. So the same command, show system resources, it will show you uptime information. So it displays the time system has been up and three load averages for the system. So you can see the highlighted one. This system has been up for 4 days. One user is logged in, and the load averages for the system. Load averages are the number of processes ready to run during last 1, 5, and 15 minutes. Load averages more than one indicates that getting more requests than the system is able to handle. Uptime display may be toggled by interactive L command. So you also observe there is a uptime information under show system info. So if I go to my firewall, I have my uptime over here. Okay, 1908. And uptime over here is 1911. Two different uptimes over here. So system time on top output is the management plane, and it may differ from show system info, which is for the data plane. So that's the reason I have difference in uptime under show system info and show system resources. Task, total number of processes running at the time of the last update. This is also broken down into number of tasks which are running, sleeping, stopped, and undead. Processes and states display may be toggled by T, alphabet T interactive command. So the highlighted one, you can see total 106 command, one is running, 105 is sleeping, 0 stopped, and 0 zombie. So CPU states, the important fields under the CPU state information is percentage ID, which means percentage idle. For instance, above shows CPU is 85.3% idle, and percentage WA, that is the percentage of the time CPU has been waiting for input output to complete. So too high may be indicative of heavy swap usage, particularly on 500, 2000, and 4000 platforms, which can cause MP issues such as dynamic routing protocol flapping due to inability to process keep alives or hellos. It can also cause issues like HS split brain due to missed heartbeats, and even process and data plane restarts due to missed heartbeats to master D. We should also check the logging rates configured on the device. Memory usage, the memory information in under show system resources. It gives you a statistics on the memory usage. It also includes total available physical memory, that is the RAM, used physical memory and free physical memory, and memory used for buffers. Display of memory information may be toggled by keyword or alphabet M, which is an interactive command. Swap, statistic on swap space includes total swap space, used for swap space and available swap space. Important to look at high swap usage, as zero swap will cause management plane issues. Your management plane may not be responding at that time when you have heavy swap usage. Low free swap, it could indicate memory leak or memory fragmentation. So in that case, you can just take out the TSF, upload the TSF to the tag case, and we'll verify why there's a memory leak on the device. Processes, every process is associated with a process ID or PID. You can see different uh, information for every process, like the user of the process, the priority of the task, if there is a resident memory used by the task, the percentage CPU, the percentage memory, the time, and the command.